Hello there! Now we will be discussing the parallel circuit. As you can see in the diagram, this is a parallel circuit. Can you spot the difference of parallel circuit with a series circuit? Yes, as you can see, there are more than one path for electric current to flow. It is visible in the arrows. So from the source, we have the total current flowing to the circuit. And then, in this node, the current will be split, as well as here. Okay. So parallel circuit is a circuit in which the current branches out, so that only part of the current beginning at the voltage source passes through each resistor. So meaning, the initial current or the total current that passes from the current source or voltage source, and only part of it will be flowing to each and every resistor in a parallel circuit. In parallel circuits, different components are connected on different branches of the wire. Here, 3 resistors are connected in different branches. Resistors in parallel, resistors are connected across each other. So as you can see, the connection is across each other. So R1 is connected across R2. So they are parallel with each other. Solving for the total resistance in parallel circuit is using this formula. Total resistance is equal to 1 divided by the inverse of R1, R2, R3, and so on. You can also use this formula, which is also the same as the first formula. Here we just get the inverse of each resistor, add them up, and then the total will be inverse. There are various forms of parallel resistor networks. As you can see, these are just some of the examples. So here is a familiar form. The resistors are connected across each other. This is also a parallel resistor. As you can see, they're just rearranged here. And this one, and also this one. I hope you have taken note the formula for total resistance. Now, let's try to answer this exercise. Find the total resistance of the following resistors connected in parallel network. So we have 3 resistors in parallel. R1 is 200 ohms, R2 is 470 ohms, and R3 is 220 ohms. So let's solve for the total resistance. So let's solve this in this bond paper. So I just rewrite the diagram. So we are looking for the total resistance. We have R1, R2, and R3 in parallel. So we use the formula. Total resistance is equal to 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. Okay, let's substitute. What is R1? We have 200 ohms plus 1 over R2 is 470 ohms plus 1 over R3 is 220 ohms. So how are we going to solve this? So first we start with the denominator. We simplify each fraction. Okay, 1 divided by, what is 1 over 200? Using our calculator, 1 divided by 200 results to 0.005 ohms plus plus 1 divided by 470 is 0.0021. Okay, and plus 1 divided by 220, yes, 0.0045. Okay, so adding these three denominators we get, so we copy the numerator 1 divided by, using your calculator again to compute, 0.116 ohms. Okay. So therefore, the total resistance is, so 1 divided by 0.0116, we get 86.21 ohms. So rounding to the nearest 2 decimals. But if you don't have calculator or scientific calculator in your home, you can use your cell phone. I will show you how. So before we get 0.0116, so how can we compute the 1 divided by 0.116? So we use the inverse fraction. You just tilt your your cell phone like this, then you look for this one. You look for 1 over x, or others it's x raised to -1. Okay, then you can see the answer, or you can just press the equal sign and to get 86.2066689. So we just round it to the nearest hundredths, so we get 86.21. Now here's the deal. How can we say that our computation is correct? So if you can see, our answer is 86.21. You compare the total resistance with the rest of the resistors in parallel. Okay, so first we have R1 200, R2 470, and R3 is 220. So you can be sure that it is correct if the total resistance is less than the lowest resistor in parallel. So in this case, the lowest resistor is, yes, R1, which is 200 ohms, and our total resistance is 86. It is lower than 200 ohms. So therefore, most probably our answer is correct. Okay, but also be careful, of course, be careful of your computation, because your answer may be lower than the lowest resistance, but it can be wrong, of course, if your computation process is also wrong. Okay, so take note of that. There's a special rule for 2 resistors in parallel. So take note, this is only applicable for 2 resistors in parallel. So in order to get the total resistance, we can use this formula. So RT is equal to R1 times R2 divided by R1 plus R2. Or in short, we divide the product of the 2 resistors by its sum. So let's take a look at the examples. So here we have 2 resistors in parallel, 10 ohms and 22 ohms. Using the formula, we get the total resistance by multiplying R1 times R2 divided by R1 plus R2. Substituting the values, we get 10 times 22 ohms divided by 10 plus 22 ohms. So that would make 220 divided by 32 ohms. So using your calculator again, we get the value of the total resistance as 6.87 ohms. So again, is this correct? So you compare the total resistance, which is 6.87, and which is the smallest value of the resistor. Yes, it is the 10 ohms. So obviously, 6.87 is less than 10 ohms. So most probably your answer is correct. Now, it's time for you to try. Solve this problem and get the total resistance for the two resistors in parallel. You can pause this video for a while you are answering the problems. Okay, did you finish answering? So if yes, let's now reveal the answer. This is for problem number 1. And this is for problem number 2. And this is the answer for problem number 3. Okay, congratulations! Your answers are all correct. Let's now try this. These are 3 resistors in parallel. Okay, can you answer them? Okay, get the total resistance for each item. Again, you can now pause the video while answering these problems. Are you done yet? If yes, let's now reveal the answer. So, since these are 3 resistors in parallels, we will be using the first formula. Here is the answer for problem number 1. And here is the answer for problem number 2. Check your answers. Congratulations if your answer is correct. If not, you can try again. You can do better next time. Okay. Now you're ready to answer your activity sheet.